study, and it was a rodent study, and they ended up taking their lowest dose of CBD that they gave the rodents was allometrically scaled based on the highest doses that went through the Epidiolex trials. Mm-hmm. So looking at 15 to 20 milligrams per kilogram body weight, scaling that down to rodents, that was their starting dose, and then they did doses that were 3 times and 10 times that. And what they found is in the doses that were 3 times and 10 times, they saw some pretty significant liver damage that started to occur in the rodents, particularly in the 10X model. They were feeding these rodents 2 grams of CBD per kilogram of body weight.
Holy cow.
Yeah, over 2 grams.
And then a journalist blows it up into, oh my God, my hair's on fire.
Right, yeah. And it's something that myself and several other people on social media that try to do science education, and particularly around cannabis, tried to actually post the article and say, no, actually read the research study, because the authors even talk about, something that you and I have talked about before, super physiological doses.
Yeah.
And that, while these effects occur, in most real life scenarios, you're unlikely to encounter them because most people aren't consuming that much. But is that something you can comment on at all? Just some of the nuances that people should be aware of when they're looking at studies that are using rodents versus humans, how that scaling occurs? And
yeah, so let me tell you a story that shocked me. I was running a R&D group that was a company. It was $1 billion company, so they had money and they had resources. In fact, my research budget was $10 million, and there had been a nutritionist there for many years that apparently was doing the dosing on any of the they did, this company did multivitamins, so he would figure out the dosing. And so when I asked him, he mentioned a study to me, and I said, what is the HED, human equivalent dose? And he gave me a blank look. Now, he had been there for over 10 years determining this company's dosing. And I said, human equivalent dose? Do you know what that is? He said, no, I've never heard of that. So he had been determining all of his dosing based on animal models. And of course, the human equivalent dosing models are based on either surface area or metabolic rate. And hopefully they're based on both, and that'll give you a more accurate read of what the right dose might be for a human in an animal model. But he had never heard of this, and so I sent him all these papers on human equivalent dose that I had on my hard drive, and he never mentioned it again because I think he was incredibly embarrassed that he'd been determining doses based on animal studies that were not relevant to humans. So there's the first piece, is like people tend to, if it was 2 grams a kilogram, they tend to just multiply that times 65 or 7. Actually, the average human now is over 65.
Yeah.
At least in the U.S., kilograms. So they tend to do that, and that's wrong. Metabolically, I think a mouse its metabolic rate is 7 times faster than a human, and I think rats are 11 times, and then you've got surface area to deal with as well. So those doses tend to change pretty significantly. But coming back to the animal model, yeah, I think we have to be really careful when we're looking at doses. Basically, anything over about 50 milligrams per kilogram is probably not realistic for human use. It's on that cusp, and that's even super high. Mm-hmm. So you get up to something like 2 grams, I mean, you're toxic. And that would happen with, look, you can drink too much water and drown, right?
Right.
So anything can be toxic, and that kind of brings us to this idea of hormesis and understanding what hormesis is. And this is that idea of a biphasic response, that a little does one thing, but a lot does another thing. Mm-hmm. And generally with this hormetic response, a little bit of a substance that potentially could be dangerous actually upregulates things like NRF2 or NRF2, it's called, which then launches this whole antioxidant system, protective buffer system. But then if you have a lot of it, it's toxic. And this is seen throughout all kingdoms, whether it's plants, whether it's animals, whether it's reptiles, whatever it is. And it's there were in the 40s, actually in the 40s is when it started losing favor, but throughout the early 20th century, there were journals based on this hormesis model. It wasn't always called hormesis, but there were a number of names for it. So we need to understand that so the American way that if one is good is not two better, anything worth doing is worth overdoing, right?
Right.
That's not true, and we need to be really careful about that in medicine, in food, in supplements, that a little bit can go a long ways, and when you take more, it doesn't mean you're getting more of the same effect. It may mean that you've gone to the other side of the curve, and you're actually getting potentially toxic effects.
Yeah, and this is something that in medicinal plant science has been well known, that there are a lot of different plants that may be helpful, but if you're consuming a lot of them every day, it's known that you start to get liver problems, all sorts of different things. Even I was talking to someone recently just about reishi mushroom tinctures, and just explaining like, hey, just understand that like this isn't something you just consume a lot of all the time and you're going to be super healthy. Like you've got to understand the dosaging, understand what you're working with, periodically take some breaks, let your body kind of reset, and then pick it up again, and give your liver a break from having to process, some of these kind of foreign compounds. I
completely agree. The idea of drug holidays should be applied to dietary supplements as well.
Yeah.
The one thing I would say though, in terms of dosing and dietary supplements, especially on tinctures, look, you got a 1 ounce bottle,
right? And
it's often now over $15. I've seen them at $25. Oh, but in the cannabis industry, they're 4 times that.
Right. Yeah. $150 for an ounce.
Yeah. Right. But the doses they have on those bottles usually are subclinical.
Yeah.
And so, for example, with echinacea, 30 drops is not going to do it, right? We're talking teaspoons if on the first signs of a cold. But I completely agree with you. The idea we need to think of dietary supplements as food items, which is really in many ways what they are. And therefore, we wouldn't eat nothing but blueberries for 5 days, right, straight. We would have judicious amounts in our diet, and that's how we need to think of dietary supplements. So, one of the things that I think isoflavones is a really good example where the isoflavones from beans, and usually people just think soy is the only place, but isoflavones are in basically almost all legumes.
Yeah. That
these compounds actually bind the beta estrogen receptor, and it's at a much lower affinity, but they still have a slight estrogen nudge towards the body. So, in our diets, maybe 50 milligrams a day was what you could get if you were eating a lot, if you were a Japanese or an Asian person eating a lot of soy-based foods. But I see supplements with 150 times that, 150 milligrams, rather than just 50 milligrams. So I worry about that sort of thing.
Yeah. Yeah. And it's weird, like now culturally microdosing is sort of in, but in the 90s and early 2000s, megadosing was really in, and especially around like vitamin C.
Yeah.
That was huge, taking mega doses of supplements to try to get certain responses that now a lot of research around that megadosing is not upholding some of the initial thoughts of what people thought that might do.